Righto, folks. Welcome to the Weeds Concurrent. Yeah, Weeds number 1A. They're the best. So we've got a smorgasbord of talks coming up in this session. Some nice prioritisation ones and a few species-specific ones. So Chris Buddenhagen is going to kick it off. He's from AgResearch, and he'll be talking about prioritising the thousands, literally thousands, right, as we heard this morning, of potential weeds for RPMPs. And on the side I heard Chris is a good poet as well, so if you need some poetry written, Chris is your man. Thanks, Chris.
Kia ora, I'm Chris, and I work at AgResearch, and we have now become the Bioeconomy Institute. So in theory, these groups are not so meaningful, but everyone there is from AgResearch except for Murray Dawson, who works on helped us with some lists of names, of plant names. And Graham Bordeaux just retired, but he's still involved. And I wanted to thank our funders, which were AgResearch and Environment Canterbury. So as you all know, there's thousands of introduced plants in New Zealand, and the typical hazard assessment method is to use this model that was developed by Falong and Williams and Halloy, and it involves 48 questions, a mix of weed elsewhere questions and actual traits like, is it toxic to animals, is it parasitic, that kind of thing. So that can be very time consuming. 8 hours, I have a friend in Hawaii whose job it is to do these assessments, and he says the average is 8 hours. So to do 20,000, it would take 94 FTEs. Pretty expensive process. And it just suggests that there could be a better way. And one of the things about trait-based analysis is there's always an exception. So if you take Tradescantia, everyone knows about Tradescantia in New Zealand. At first glance, it doesn't even produce seeds in New Zealand. You wouldn't think on a trait-based basis that that was an awesome weed. No way. So we developed a rapid algorithmic method, the CPG model. It has 3 variables only, not 48, like that other model. The climate composite match index, which comes from Climex. The number of publications about it as a weed, and we use AI to scan weed science article abstracts and decide whether or not that describes which weed species are mentioned and that it is in the context of being a weed or an invasive plant. And we look at global occurrences from GBIF. And there's been a lot of people talking about GBIF and iNaturalist today. And I just want to say everyone here should be using iNaturalist and contributing records to that. It helps researchers globally and locally, and it's great. So I'm going to make the distinction between hazard assessment and risk assessment. Hazard assessment is, could it become a weed? That's what we're doing. Risk assessment is, it could become a weed, and how bad is it? What's it going to do? What's the damage? We're not taking that step, although the information here you can sort of see is pretty relevant. If you've got all those publications already collected and you know that what they're talking about, you can start to get an idea of how bad a weed it is, but that's not what we're doing. We're doing something else. So we compared our expert assessment, which we did ourselves for 428 randomly selected species from those 20,000. And you can see that the knot and major and minor weeds on the left-hand side here are, where is that? Right here. So these are the non-weeds, and they get a low score, and the major weeds are reliably distinguished. And with a cutoff of 36 points on our CPG score, we can distinguish with a 90% sensitivity and specificity that the difference between a non-weed and a major weed. And then here's the Falong model. They only assessed, that was published in 1999, and they actually selected kind of a non-random list of mostly weeds and a few non-weeds, and our model performed pretty well against that as well. And you have to realize it's not measuring exactly the same thing because they have 48 questions. Ours doesn't. And the best predictor from all those 48 questions about whether it's a weed is weed elsewhere, and that's what we're doing. And they didn't use climate in that model in the way that we are. We're doing actual climate assessments based on occurrences globally. They were just generally answering that it was bad because they didn't have enough information, so they took a precautionary approach and said the climate was a good match. And then we compared our model against 5,000 species from Rod Randall that he assessed in a kind of global scoring system that has to do with weeds of its kind of history of weediness globally, nothing to do with the location, right? So our model performed well against other people's models and had a good predictive ability. And so our CPG score roughly ranges between 0 and 100. So what I'm actually talking about today is the value of doing regional assessments. The P and G variables don't change. That's publications that are relevant for a species, and the global occurrences. They don't change. They come from GBIF. Climate suitability scores are expected to differ. So here we looked at Canterbury, and this is comparing Canterbury's future climate to the rest of New Zealand's current climate, and you can see that Canterbury's future climate matches a lot of the North Island now, and that's the light yellow, the yellow color, and the lightest green. And it's kind of inland a little bit, not too coastal, but you can see that Canterbury's future climate matches the current climate. So this is how we're also comparing to the rest of the world. And we can, so we're also including assessments for today's climate or past climate and future climate in our model. So we can make those comparisons to which species might be sleepers and might be released. So we divided Canterbury into 2 regions using a clustering algorithm, and it happens to capture also quite a bit of the land use difference just by having those 2 regions, the high and the low areas. And so here, this is New Zealand's, Canterbury's future climate compared to the rest of the world, the highland and the lowland. So you can see in the highlands, you get just some of the east coast of the US and not much else. But in the lowlands, that's Canterbury's future lowland climate, starts to look very similar to the current climate globally for all those red spots, right? And so you can see that Canterbury's future climate is quite well suited to quite a lot of the planet. So that means that any weed that's in those areas will get a high score in our C model. Okay. So the P variable, here's some of the weeds that came out in the top 15 or something. They're globally famous. A lot of them are crop weeds, but not all of them. We have, well, you know, adratum and lantana and stuff like that. So the only 2,000 species out of, we were able to scan 44,000 science abstracts using AI. Quite a lot faster than doing it manually. I think we'd still be doing that if we'd done it manually. And it's about 80% accurate. We tested AI versus us. So we were able to get a CPG score for 18,000 out of the 22,000 species. The reason we couldn't get a score was usually because there was no global distribution information about a species. So you can see that's the kind of data that we're using to make a decision about a plant being suitable to New Zealand or not. And so comparing national versus Canterbury, and that I don't know if you remember, I mentioned there was a 36 score in our CPG score was a kind of a threshold at the beginning. Compared to the national, in the lowland, 9 move up above that threshold, 238 move down, and the rest either stay above or below that threshold. So, and then for the highland, none move above, 1,300 move below, and 300 stay above that serious weed threshold that we identified. So you can see just from that little test that you'd get a different answer if you use the national rank that we have, which you could use, than if you use a regional assessment. So this is the only thing that differs between the scoring is the C value, which is the climate match. So if you can see that a small number of species become more highly matched for the highlands and a small number there as well for the lowlands. But mostly Canterbury's a little less suited because you can imagine that when you take the whole climate, all the climates in New Zealand, you're going to get you have a lot to sample from, right? So there's a lot of climates to sample from. So there is value in doing regional assessments, and I imagine that if we did Northland, we'd get quite a different answer as well from the national assessment. And so what would you do next after you have your hazard rank for 18,000 species? You'd want to know the usual stuff, right? Is it feasible to manage? Are they limited in distribution? Is the distribution that you think you know about that species really the distribution? You might need to do some surveys if it's a high-ranked species. You could assess the potential impacts under shifting climate, and we provide some of that data, but you could do more. The feasibility of management and whether you should include it in your RPMP, all those kinds of things would play into it. But what we're talking about here is not ignoring a species, right? So, Environment Canterbury has a very onto it. Morgan Stanley, he's involved in all the decisions, and he gave us 1,100 species that he was worried about, but he could miss one that was important, couldn't he? I mean, it's just kind of, there's too many to think about. So here, my future goal would be to assess all the plants in the world. No problem. It's possible with an algorithmic approach. It's just getting all the names, getting a list of all the names that that is solid is really hard. Surprisingly difficult part of the problem. So in our report to Canterbury, we provide an online book, and it has different sections, and including methods and the data, downloadable Excel spreadsheets and maps and so on. And so this is an ebook produced from our code and served online. And if anyone wants to see what it looks like, I'm happy to show afterwards. And it's updatable at any time. We'd need to do the assessment every few years as more publications come out about a plant as a weed, or as more occurrences get online as we get more and more people using those iNaturalist and similar platforms. So, your answers could change over time. But in general, I can say that the weeds that are managed in New Zealand have really high ranks. The weeds that are on our PMPs generally have really high ranks. So, we are actually kind of already onto it, but there's probably things that we're missing that should be included. So in conclusion, we can rank thousands of hazards. Regional ranks will differ from national ranks. Hazard ranks could be made available by region as an updatable ebook. I would hope that they would be all public, but at the moment we have the one for ECAN behind a password. And the hazard ranking process provides a means to shortlist species for full assessment of management costs, benefits, and feasibility. So this, in theory, this allows you to both say, we've considered everything, and in our next step, we're going to save money and not deal with these ones. And there might, when you're dealing with 18,000 species that are assessed, the top 10% is 1,800 species. So, you're still going to have to be thinking about what's in there. And a lot of those 1,800 species will already be widespread weeds in New Zealand. So you'd ignore those anyway. But the point is, you're able to shortlist. So I'll just, because I think I have time.
Yep, you still got time.
Yeah, I will show you, this is my last slide, and it just shows you the shifting climate situation for the 25 highest ranked species for Canterbury. And the idea here is compared to the past climate, how does the CPG score change because of the climate score, right? The climate suitability matching. And you can see a number of these species get worse, and a number get, they become more suited, and they become less suited in the future. So plants can have that possibility of going, weeds, some of, a lot of these are all mostly, because they're highly ranked, they're a weed somewhere, if they're not already a weed in New Zealand. And, you can see gorse doesn't get better, it gets worse. So, just in case you were wondering, it's not going to get better, it's going to get worse. And privet, looking a little worse. And then there's a lot of these things don't occur in Canterbury or are rare. So you could imagine that some of those things could be worth including for some sort of exclusion or other category on our RPMP. And if you have any questions, I'm happy to take them.
Any questions? We can just take them until the bell goes. Yep.
So does your model include an iNaturalist entry as a publication? Because for me what's really important are these new invaders, and they're frequently picked up by community and logged on iNaturalist by community.
So the P and the G score, which is publications and global occurrences, are both enough to make your species a bad weed. If you don't have any publication, there's a lot of global occurrences, including in New Zealand, then it gets more of a score. So all those iNaturalist observations are on GBIF, and that's where we're getting our information. And when I say they're on GBIF, it can take quite a while for some of those iNaturalist observations to get uploaded to GBIF. There seems to be quite a delay, but it's not years, it's months. So, we're able to always update this as well, including with any observations that are made on iNaturalist. Yeah.
Cool. Any more questions? No? Right on the bell? Awesome.
Oh, yeah, okay.
Yeah, no, sorry.
Yeah.
Awesome. Thank you so much.